Next up, we're going to continue the idea of the sample space and theoretical probability, and we're going to look at the keywords and or. In our next example, it says, consider rolling 2 fair dice and adding the outcomes. Which sum is more likely to occur, a sum of 5 or a sum of 7? When I'm rolling 2 dice, I'm going to use a tool known as the addition table. There are going to be 36 outcomes that are possible here. I'm going to look at all 36 to help me decide which is more or less likely. So across the side here, I'll put my first die. What I get a 1, 2, a 3, a 4, a 5, or 6. And across the top, I'll put my second roll. And again, on that second one, I could get a 1, 2, 3, 4, 5, or 6 on that second die. And then we look at this like a matrix, and we add each row in each column. If I got a 1 on the first one and a 1 on the second one, that would be a total of a 2. A 1 and a 2 would give me a 3. A 1 and a 3 would total to be 4. 5, 6, and then 1 and 6 would give me a 7. For this second row, 2 and 1 would give me 3. 2 and 2 would give me 4. And it's just going to walk its way up to 8. For the third row, it's going to start with a 4 from that 3 and 1, then go to a 5. And you begin to see a pattern both horizontally, going up by 1, as well as vertically. If you go down the column, it goes up by 1. So this must be a 5, all the way up to a 10 in this row, a 6, all the way up to 11 in the fifth row, and the final row, it'll start with a 7. Go all the way up to 12. 12 is the maximum that we have here. If you get a 6 on the first die and a 6 on the second die. And now I can see along these diagonals which is more likely. I have 4 5s along this diagonal, and I have 6 7s along this diagonal. To use my notation, I could say the probability of a 5 would be 4 5s out of 36 total. If you count all of these up, that would give you 36 as well. You've got 6 in each row times 6 in each column. 6 times 6 gives you the 36 total as well. As far as my 7 goes, probability of 7 would be 6 out of 36. This is 1/9. This is 1/6, and it's helpful to have those decimals to compare. So over here on my calculator, I'll say 1 divided by 9. The probability of my 5 would be 0.1111 to 4 places. Then 1 divided by 6 for the probability of 7, that would be 0.1667 if you round that to 4 places. I can see the probability of a 5 is about 11%. The probability of a 7 is about 17%. So a sum of 7 is more likely to occur based off of my sample space here. Moving along, 2 keywords that we're going to see over and over throughout this chapter and into some future chapters as well are and or. Think about and to begin with as the overlap. Whenever you have a physical representation, some sort of graph, think about and as overlapping. And think about or as the total. As an example to clarify this, I have a Venn diagram showing what people had to eat at a Memorial Day cookout. I had Faye, Tay, and May who decided to have a hot dog. I have Kay who decided to have a burger. Ray and Jay are in both circles. They had both a hot dog and a burger. And then Ron, who is in neither circle, didn't have a hot dog, didn't have a hamburger. A asks, what is the probability a single person had a hot dog and a hamburger? Well, we know there are 2 people out of 7 who had a hot dog and a hamburger. That and is where I'm overlapping. That fraction will not simplify, but I can take 2 divided by 7, and I would get 0.2857 or 28.57%. B asks, what is the probability a single person had a hot dog or a hamburger? So I want to know how many people had hot dogs or hamburgers. Well, Faye would be counted because she had a hot dog, so would Tay and May. Kay would be counted because she had a burger. And Ray and Jay are also counted because they had a hot dog as well. They had a burger. So they would be counted in both groups. Or is the total of everything. The only person who didn't have a hamburger or a hot dog would be Ron. So this would be 6 out of 7. As a decimal, this would be 0.8517 or 85.17%. Note that these are not complements because they would add to be over 100%. They're not events. Finally, in C here, what is the probability a single person had no hot dog or burger? Well, that would be Ron. He's the one person who didn't have a hot dog, didn't have a burger. 1 divided by 7 gives us 0.1429, which is 14.29%. And I see I've made a quick mistake. Let me fix that. In B, I got those numbers switched. It should be 8571 and 85.71%. And we can see that B and C together are complements. B was Faye, Tay, May, Ray, J, and K. Part C was its complement, the not. What's left, that would be Ron for part C. So we've included the entire sample space with both B and C.